Roots, roots, roots. Polynomials and their roots. It's an important part of them. Now today we're going to talk about a specific type of polynomial, and that's a quadratic. That's things that have x squared in it and nothing bigger, so no cubes or to the fourth. The biggest exponent in a quadratic is a squared, or a 2. And it turns out the discriminant can tell us what kind of roots a quadratic function has. Now you may be wondering, what in the world is a discriminant? It sounds like discrimination. Well, not related at all. So let me just remind you of the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is actually a very specific part of the quadratic formula, and it's the part under the square root. Now notice, it's not the square root, it's the part inside the square root. So the discriminant is just b squared minus 4ac. It turns out the discriminant can tell us what kind of roots a quadratic function has. So the discriminant is b squared minus 4ac. And if you plug in the b, that's the coefficient in front of x, the a and the c into this equation, a is the coefficient in front of x squared, c is the constant, the number without an x. If your result is positive, if it's greater than 0, that means 2 real roots. If the discriminant is equal to 0, you have 1 real root. Or some other books and things will say you have 1 unique real root. Because what actually happens, just so you know, when you have the discriminant equal to 0, is you have 2 roots, but it's the same number both times. So for something, if you factor it and you get x minus 2 times x minus 2, well, technically I have 2 roots right here because I have 2 different pieces, but both of them are going to give me x equals 2. So I do have 2 roots, but they're the same one. So they say 1 real root, meaning there's only 1 unique real root. So there's still technically 2, because it's squared, it has to have 2, but both of them are the exact same number. But then if the discriminant is negative, it's 2 imaginary roots. So again, we will plug in these numbers. If the result of b squared minus 4ac is positive, then there are 2 real roots. If it's equal to 0, then there is 1 unique real root. And if it's negative, then there are 2 imaginary roots. So let's try this out. First step is to make sure we know what a, b, and c are equal to. A is the coefficient in front of x squared, so that's 1. B is the coefficient in front of x. C is the 36. So the discriminant is b squared minus 4ac. So I do 7 squared minus 4 times 1 times 36, and my result is negative 95. Since I got a negative answer, that tells me that this quadratic has 2 imaginary roots. So just from looking at the discriminant alone, I know it has 2 imaginary roots. Okay, here's another example. 2x squared plus 11x minus 45. We need to label a, which is the coefficient in front of the x squared, so it's 2. B, which is the coefficient in front of x, that's 11. And c, that's the negative 45. So make sure you do hold on to any negative signs that go along with these. So we do b squared minus 4ac. B is 11. A is 2. And c is negative 45. So make sure you do include those negatives. So I type in 11 squared minus 4 times 2 times negative 45. It's probably a good idea to put parentheses around that negative 45 in your calculator just to make sure. And the result is positive 481. Since I got a positive result, that tells me there are 2 real roots. 2 unique real roots, in fact. So there's 2 of them, and it's 2 different numbers. For our last example, f of x equals x squared minus 6x plus 9. So our a is 1. There's an understood 1 in front of that x squared. The b is negative 6, and c is positive 9. I do b squared, negative 6 squared, minus 4 times 1 times 9. Because it's b squared minus 4ac. Negative 6 squared is positive 36. Make sure if you put that in your calculator, you do include the parentheses or you'll get the wrong answer. 4 times 1 times 9 is 36, so we get 36 minus 36 equals 0. When the discriminant is equal to 0, that means there is one unique real root. So you need to commit these rules to memory. If the discriminant is positive, there are two unique real roots. If the discriminant is negative, there are two imaginary roots. If the discriminant is equal to 0, then there is one unique real root. Again, you can think about it, there are two, it's just they're the exact same number. So there's just one unique real root when the discriminant is equal to 0.